Alright, next section of Chapter 6. We're going to start with Objectives 114 to 121, Ratios and Proportions. So we're going to kind of just continue and add on to a little bit more of this. So a lot of this may be a repeat and look similar. So there's no terms for this section, just all examples. So when we jump into solving equations, or solving proportions in this case, we're looking at what number times 7 gives me 21. In this case it's 3, so we're going to multiply 3 times 9 and gives us 27. So there's no cross multiplying in this case for the solving. Here we're going to go backwards. If you go left to right, you're going to multiply, right to left, you're going to divide. So in this case we're going from 20 to 5, we're going to divide by 4, which means we divide 24 by 4, and that gives us our 6. And then we have 6 into 138. And if you cannot see right off the bat what that number would be that you multiply it, take this number, divide it into that number. That'll give you the number. So whatever this was, the answer is also multiplied times the top, which in this case was 23. So we have 23 times 3, which gives us our 69. Our average speed similar to unit rate that we talked about in the last section. 148 divided by 4, because we're finding an average, so we're going to divide. So we would divide it, and it comes out to be 37, which would give us an answer of 37 miles per hour. So divide 4 into that. That leaves me with 1 hour on the bottom. And again, that's what we define as a unit rate. Next examples, I've given you titles. So in this case, we're looking for gargoyles. What we're going to do first is we're going to do a couple things before we actually get into this. This is going to be actually a fractional ratio. So instead of a proportion, we're looking just to solve and set up a ratio. So what we're going to do is you're going to be given two numbers in the problem. They're going to have terms identified by them. So wings spread, there's 600. There's 120 wings folded. What we're going to do first is add them up and get a total of 720. So this total is going to be important because in a fractional part, the total goes always at the bottom. So to set up our ratio in this case, we're going to be looking for what fraction are they looking for. And in this case, it's wings folded, so we're going to look at the 120. So we're going to take our 120, which is part of the total of 720, and we can cross out our zeros to get rid of that, so we just have 12 into 72. We know that 12 goes into 72 evenly, so 12 into both of those gives us 1/6, and that's the fractional ratio of what's on the castle. Our other one is total population. They're going to give you people, in this case males and females. So for every 9 males, there's 4 females. They're going to tell you a total of the males that are in the college or university that you're dealing with. In this case, it's 10,764. So the first thing we're going to do is set up our proportion. So males we can put on top. We could also put it on the bottom, which means our females would go on the top. So we have 9 over 4, so 9 males, 4 females. Our total of males here, and we're looking for the total of females here. So in step 2, we're going to cross multiply up here. So we end up with 9x. 4 times the 10,764 gives us 43,056. Our step 3 is we're going to divide. That gives us the total amount of females, but we still need the total population. So we're going to take these two numbers for the males and females, and we're going to add them together and get our answer of 15,548. So it's a way of making sure that you read the question to understand what they're actually having you find. The one that's going to take you the most time is the fractional proportions. Please take your time. Please show your work. It's going to make it a lot easier if you go down the paper and you're very neat in this section. So it's going to set up looking like a proportion but with fractions. So in this case we're going to solve it the same way. We're going to cross multiply, so we have 1/5 times n, 3/5 times 3/5. We're going to bring this down. We're going to solve and simplify this, taking this, nothing cancels. So 3 times 3 is 9, 5 times 5 is 25. We're then going to multiply by the reciprocal, and that goes back to a section that we did earlier in the first semester. So we have our 5 over 1, which everything cancels out to leave us n. Our 5 over 1 on this side, we can cancel the 5 with the 25, leaves us with 5 here. So we have 9/5. Now, you can turn this into a mixed number if you'd like. I would look at your answers and see what they leave them as. If they leave them as impropers, feel free to leave it as impropers. We're going to take one and turn it into a mixed number so we refresh our memories on that. Second part, now we can throw mixed numbers at you. So in this case, anytime that you have mixed numbers in your proportion, turn your mixed numbers into impropers as you cross multiply. So as I'm cross multiplying here, I'm going to change that into 9/4. And as I'm multiplying here, I'm going to change it into 8/5. So I'm going to simplify these by multiplying, but I'm going to cross cancel first because 4 does go into 8, leaves me with 2. So I end up with 6/5 on this side. Bring my 9/4 down. I'm going to multiply again by the reciprocal to both sides. These drop to 1, which is what we want as x. I'm going to simplify here because 3 can go into 6 and 9, leaving me 2 here, 3 here. So 2 times 4 is 8, 5 times 3 is 15, and it's a proper fraction, so we're going to leave it. Our last problem for this section, a lot of mixed numbers, but don't worry, turn your mixed numbers into impropers as you cross multiply. So we get 11/3 times n. We end up with 29/6, 14/3. And again, I'm looking to cancel when I can. In this case, 2 goes into both 6 and 14, leaving me with 3 and with 7. So I have 29 times 7 gives me 203. 3 times 3 gives me my 9. So my 11/3 multiplied by the reciprocal to both sides. These go to n. Now I'm going to cancel my 3 with my 9. Leaves me with 1 and 3. So I'm going to multiply 3 times 11 gives me 33. 203 times 1 is 203. And in this one I'm going to turn it back into a mixed number because maybe my answers are all mixed numbers and that's what I need to have it in. So in here I'm going to take and divide 33 into 203. Goes 6 times with 198. Remainder of 5. So when I turn it in, my whole number is my 6. My 5 is my numerator, and whatever I started as my denominator ends as my denominator in that section. So there's your fractional proportions. Take your time. Show your work. Then they just ask you to identify fractions. How do you know if a ratio is a ratio is also a proportion? Is the proportion must be equal. So in this case, if we look at 3 to 18 was multiplied by 6. If I multiply 6 times 7, I get 42. So in this case, you would say, yes, that is a correct, and that is a proportion. 3 times 8 gives me 24. If I multiply the 8 times 7, I do get 56. So again, this one checks out, and it is a proportion. 3 times 5 gives me 15. 7 times 5 gives me 35. Yes, that is a proportion. They're equal to each other. 7 times 3 gives me 21. 7 times 7 does not give me 29. It should give me 49. So in this case, no, those are not proportional. They're not equal. 3 times 4 gives me 12. 8 times 4 should not give me 40. It should give me 32. So this is our no. 3 times 4 gives me 12. 8 times 4 gives me 32. So that's yes. We could go backwards in this case. If I divide by 8, I get 3. If I divide 64 by 8, I should get 8. In this case, I went to the left. So that is, it is proportional because they are equal. If this number gives you what that is by multiplying it, that's what you're looking for. 3 times 5 gives me 15. 8 times 5 gives me 40. And that also is equal. It's proportional. You can also cross multiply in there, but I wouldn't suggest it. Just multiply and you'll find that out. And yes, you'll have to do 4 questions or 4 problems on it. Cyclist problem is one where you do not have a ratio. All you're going to do is simply multiply. So this year 1 2/5 times as many cyclists entered the race as last year. If 70 cyclists entered the race last year, how many cyclists entered this year? So we take our 1 2/5, turn it into a mixed improper fraction, and we simply multiply by 70 to find out how many cyclists will enter the race. So again, we cross cancel. 5 goes into 70 14 times, so we have 7 times 14 gives us 98. There's also a couple questions on there. If you're asked to write it 2 ways, just do it one way. In this case, it's flower bouquets, so 64 bouquets, 16 hours. They give you how many would it take to make 640. What you do is basically multiply both top and bottom times 10 and get 160 hours for that. Our last one is similar to what we did before. We're just comparison, solving as a unit rate. We take our value over our amount, divide, value over our amount, divide. So our step 1 is just divide each one, figure out what you got. Step 2, you want to read through the rest of the question and see what they're asking you for or what their choices are. So they may have you subtract these. They may just ask you which is the best or which is the correct choice, or what's the difference between the savings. So make sure that you read your questions as you go through. That's the end of this section. Good luck. Bring your notes.